Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about Supersonic passenger jet. So let's dive deep into it. So what the heck is the idea? Well, idea is long ago, as in 75 years ago, we humans pushed through the sonic barrier. As in 1974, human first, this dude literally pushed through the sonic barrier. And be mindful, the reason we call it sonic barrier, there is this naughty puppy, is that when you are traveling subsonic, everything is chill, everything is fine, all your calculations or your aerodynamics works. But when you try to push that puppy it to almost Mach 1 speed, there is a region just before that, like let's say 0.75 to 1 Mach. It would be tighter depending on altitude and humidity and all that, but there is a region, and more you try to push it, the more unstable airflow you get, and at that point it's risky AF. Many pilots have tried to breach through that, but a lot of them did not end well. Let's just put it that way. Many people tried and lost their life. So he was literally pushing his luck, and be mindful, we did not have understanding about it. What the heck will happen if you really manage to push through? So just with a rocket powered plane, it's like push through it. Now here's the things changed. The moment that happened, people realized there is this naughty air zone. The moment you push through it, the equations change and everything becomes stable again, and there is nothing after that. Meaning, once you cross Mach 1, you're like, okay, what about crossing Mach 2? Oh, you can do that. What about crossing Mach 3? Oh, you can do that. What about crossing Mach 4? No problem. Go as fast as you can go, as long as you can survive the heat and as long as you can produce the power. You don't have to worry after that. So it happened. The idea is that we know there is just a thin barrier of naughty air. If we can just push through that speed region, we can like really achieve good things. And we always want to go fast. Like that's a human thing. We want to go fast. Many times we cannot comprehend the world before World War, because you have to understand that jet took its sweet time to be developed, but jet literally shrunk the planet to such a point where if you are rich people or just like upper middle class kind of people, you can travel to other country inside a day. In some scenarios, especially in Europe, literally in hours. So like, does that have an impact? Yes, the world trade literally relies on that, because before you do trading, before you have like container ships going, people have to go back and forth and see what's available, how things work. So more people are interconnected, the more world trade happens. For that reason, we needed to shrink the world, and jumbo jets allowed us to shrink the world very effectively. Basically, it became a thing. Before that, like let's say before World War I, if you have talked to anyone, it's like, you know what, I'm just gonna feel like it, I want to go for a trip to Europe. They're like, okay, how many months? That's how they would have asked about it. It's like, how many months? Because again, ships would take time to go there. Now you'll be like, no, man, I'm just gonna Friday night I'm gonna catch a flight and then just gonna sleep in the plane. And then yes, many planes are overnight, so you can sleep in them, and then you can just like fresh out on a different country. So we always want to go faster, and it does make the world smaller. How small? Well, London to New York will go from 7 hours to 3 hours. So that is significant change. And some people back in the old days of 2003 used to flex that that's how they were flying. They were flying only in Concords back and forth, and they were like, yeah. I eat lunch here, I go there. It's like, yeah, that was like uber flex of that time. Like you have to be so high level to flex on that level, where it's like the tickets were like around $10,000 or 10,000 euro of 2003. Do not even convert it into inflation money now. So idea is always there. We want to push through it. Once we realize that we can just push through it, the moment you go through that region, the airflow becomes stable again. We can just go through. It's all about energy and temperature management. And this puppy actually crossed around Mach 7. So we know how to do this. So are there daddies into this? Well, yes, there is granddaddy, which is this puppy. This is SR71, 1966. That's old, like literally granddaddy age. And one of the interesting part about this was the first was hot body, meaning everything in the plane was hot. Now if you're like, wait a minute, wouldn't that mean the aircraft will overheat and the people inside would be poofed? Well, yes. So how the heck they were cooling it? If everything is hot, how the heck you cool it? Well, they took technology out of rocket engines. They were like, what if we take a cooling system, we cool it? They're like, okay, sir, good, awesome, GG. Where would you dump the heat? It's like, what if we dump the heat into the fuel, jet propellant that we are using? We heat that fuel up, and then when it becomes too unstable to store, we just like out of the engine. Don't even give a damn about it. So that's how this can survive the hot body system. And this can easily do Mach 3.2. Let that be very clear. It's unclassified one. More than enough evidence, more than enough stuff is around that this could go a bit higher than that. I do not think it would cross Mach 4, but it should be able to go a bit farther, because the closest missile ever managed to reach to it was 1 kilometer. Now, aren't missiles faster? Absolutely, they are much faster, but you have to understand, they start from zero. This was traveling already, going, whenever it's going through dangerous territories, already in Fast and Furious mode. So it's traveling at Mach 3. You're starting. You are at Mach 2, still at 3. You're at Mach 4. Whoa, whoa, whoa. You're catching up. You're at Mach 5. Whoa, you're getting seriously close. And it's like, yeah, you ran out of fuel. It literally outran fuels of missiles. That's why it was not intercepted. So that was the granddaddy. Then we had the daddy. Daddy happened in 1976. That was Concorde. Most of you have known that, and maybe your elderlies may have traveled into it, unless you are like very wealthy. So it was not a normal people thing. Let that be very clear. Not a normal people thing. But it was warm body. To compare to, like, the heating is not linear, meaning it's like, oh, Mach 2 it will be this much temperature, Mach 3 would be no, it's exponential. So Mach 2 would be like, okay, it's hot, you can have aluminum. Mach 3 would be like, brah, anything below titanium, you're dead. So it was warm body, and it can easily do Mach 2.2, and they did, just to have that digital display and show everything fine, Mach 2. They were always like Mach 2. So that's what they did. Now his deal. This puppy did all that using a clever engine technique, where there were turbojet engine in the core. Everything's fine, everything is good, and it has a little bit of air bypass, but it had pipes. So those pipes were magic pipes. What they did is, once you started to push the jet as fast as it can go, the pipes will open up. It will suck in air directly from the shock compression and dump that air directly, bypassing the engine core, dumping into the afterburner area, and there you dump fuel. Basically, it made it into pseudo ramjet. That's how you can sustain very high speed without consuming bonkers amount of fuel. Many planes could touch that. Like, there were MiG series planes that were modified to touch this speed. The only difference is, this is a marathon runner at Mach 3, meaning it does not go to Mach 3, it starts at Mach 3. It's like, bro, I'm cool. Like, the only reason it has to slow down is just to refuel it. Once it refuels, it's like, bro, I'm good. Goes at full speed. The only limitation of this puppy, some of the missions, if I'm not mistaken, is around 50 hours long. Like, did it flew for that long? Obviously. The issue was the fuel ignition system. They could not figure out an electrical ignition start. So they had T-tap. Yes, the same T-tap was used by SpaceX to ignite Falcon 9. So they had to have T-tap shots. So as long as they had T-taps, they can reignite the engine, no problem. If they ran out of it, they had to land. So it was really amazing for its time, but it was using afterburner. So very good at Mach 3, but really not fuel economical. So somebody came up with the idea, what if we take the jet engine? That's awesome, GG. But what if we put it inside a transformer? Now what will transformer do is, like, jet engines do not like high speed air. You will think they liked it, they don't. If you put them in an airstream that is like at Mach 2, yeah, no. The engine will say no. So what somebody clever did is, like, what if we put engine in a nacelle? We're like, okay, don't we do that already? Yeah, we do that. But what if we had shock traps? Basically this puppy. So shock trap, that's why engine starts from here. This is the shock trap. So idea is, when you are at high altitude, you are traveling fast. Okay, Mach 2. Okay. Now what do? This is high speed, low pressure air. Really dirty for your engine. You are doing your engine dirty if you do this. So what they did? Shock. Boom, bim, bam, boom, shock waves happened, and then you got 0.5. What does that mean? That means now you have transformed it from high velocity to low velocity. Now again, energy cannot be created, something must change, of course. Low pressure, high pressure. So from engine's point of view, engine is like, at high altitude, it's like, slow, high density air is like, that's why I did not need to worry about afterburners. So, like, it was getting such a cool, fresh, high pressure air. It was like, I get you, fam. It was creating GG thrust. And just to make sure that it has extra oomph, it has converging, diverging nozzle. That's why nozzle also had that intake geometry structure. Same way you have rocket nozzle. So it was getting a lot of oomph. Basically, engine, from engine's point of view, was in a subsonic region. From outside, it was traveling at Mach 2. Very clever design. Now you will hear this term, super cruise. What does super cruise mean? Super cruise is a very simple thing when you are doing something like this. Basically, anytime you are crossing Mach 1 without consuming afterburner, if you do not have what we call reheat, it's classified as super cruise. Now modern fighter jets, some of them can do super cruise, meaning they can not only push through just on raw jet engine power, they can push through the sonic barrier, and they can sustain Mach 1.2, Mach 1.5. Some can claim Mach 1.7 at super cruise. Now does that matter? Absolutely. If you are doing basically super cruise, that means you can go much further compared to even someone who has afterburners. Because again, if you want long duration flight, you need to have basically super cruise. Only that makes sense in commercial setting. This again, it had a fancy fuel. On top of that, it was designed, everything around it, fuel tank capacity, everything was designed for Mark 3. So at Mark 3, this is like, bro, I'm the fastest thing alive. And it was so expensive that government was like, yeah, let's throw this puppy away. Let's just put satellites in space, hundreds of them. Yes, that's how expensive this was. So these are the daddy. And this was a very clever engineering. Somebody is like, what if we put a transformer? I'm like, nice. High pressure, basically low pressure, high pressure, high velocity, low velocity. So NASA comes into the picture. Now NASA is going against Federal Aviation Administration, FAA, and be mindful, NASA is responsible for both space technology and aeronautical industry. So there is a A there. So NASA is very responsible for that, and the FAA had created a decree after Concorde is that banned commercial supersonic speed, meaning you cannot go supersonic if you are not military. And even military has like, unless it's an emergency, meaning if POTUS security is compromised or Olympus has fallen, only then your jets are allowed to like go supersonic. Again, if something emergency happens, you have the button to press, but other people cannot press the button, quote unquote. So that's a law that is banning it. So the only way other companies can make sense is that like if they are doing over the ocean travels. So, and again, this was another issue with Concorde. Concorde did not have enough range. While it had the speed, it did not have the range. So that's why most of the time people talk about like, America to Europe, basically. They were not talking about like America to Australia. It's like it did not have the range. So band of super system, even though there are many locations in USA that like love this supersonic flight because of the noise pollution and the fact that it was producing around 130 decibels of sound, give or take, it was too brutal. So basically FAA banned it out of public concern, and there were experiments done where it's like small fighter jets were doing this Mach speed, and reality was the same. The energy is just too much. People cannot just ignore it. They will get irritated, harmed. It won't be like, oh, I get used to it. No, it was brutal. So people learned it the hard way, and FAA had to ban it. So NASA is trying to prove that with modern designs, basically learned from all the mistakes of the past, we can create a new design doctrine that will allow you to have a jumbo jet that is traveling at sonic speeds, as in Mach 1, Mach 2, and it will not have that kind of oomph, the noise. And the dB should be brought down to what we call below annoyance level, meaning it will not annoy you. It will be like, oh, plane went by. It should not be like, whoa. It should not be like that. So this was the first jet they built, but not built as in like modified, and you can see it, like the design feels very weird. Yeah, it was designed in such a way that the sonic energy is dissipated upwards and it reduced the pressure created. Now there was a plane chasing it, and the result was around 30% reduction. So this proved the concept that it can be done. They're like, okay, we built the first generation of fighters, good, awesome. What if we built take the same learnings from it and made a different modified design? Okay, does it work? Okay, it did. So now they are taking knowledge from this puppy, putting into this puppy. This should have flown by 2022, but world went boom, so it got delayed. It's under construction right now. I have linked the video down below. So this puppy should, this was like a little bit pressure drop. This should be like eliminating it, meaning majority of the shock energy should going upwards towards space, and very minimal should go downwards, very minimal. And how they are achieving this? Well, they are using what Navy ships use. Navy ships have a bow. Like why? Like why it's not completely smooth? Well, they are using noise cancellation. So destructive interference. So they are creating one shock that is offset from the another shock, and both of them are just fighting and cancelling each other out. So that's how NASA is cancelling the bottom part, and upper part they are just like all the design elements in such a way that all the energy goes up. So that's how NASA is gonna prove it. Now, is there a benefit to this? Absolutely. Without this, no supersonic passenger, like flat out, that could fly over USA. So they have to build it. NASA has to build it, fly it, and prove the design philosophy that it does work, and people should not call in police where it's like, what happened? Why we are hearing boom, boom, booms? If NASA can prove that, then it opens the door. So what are the issues here? Well, issues is the boom part. Many times people, again, in early days, because you are in a static location, you are watching a plane, you would think it's just like, it's not that. It's like, that's the problem with that. The shock wave is continuous as long as you are sonic speed. So boom is continuous shock to the ground, and it is meaning if you're flying over a populated places like India, yeah. Now again, Indian homes won't be affected. We built homes out of bricks. It's not be affected, but people would be annoyed. So boom is continuous shock, and it has to be handled. Now, there is a contradiction here. The contradiction is, while did NASA figured out engineering doctrine that will allow your craft's sonic signature to go down, it comes at a cost, and not money cost. It comes at a payload capacity, meaning how your geometry has to be built. Fundamentally, it will reduces your payload capacity, meaning if you are building Concorde with the same design philosophy that they are covering out, your capacity would, let's just say, will go from 100 to 50. Again, that makes it economically hard to justify. So that's the biggest problem. Yeah, so it's like, can we make a jet that is like fast and quiet? Yes. Can we do it economically? Well, depends how expensive each individual is. Basically, how expensive each ticket is. And physics is clear. Let this be very clear. I've seen way too many people using fancy math to confuse people, but let this be very clear. Physics is on this is like Newton figured this out. Like, do not try to fight it. Energy needs is directly proportional to your speed, meaning faster needs more energy no matter what you do. Meaning, if I give you 100-ton object and you're like, you're in vacuum, you're like, okay, push this 100-ton object at Mach 1, it will take X amount of energy. Push this object at Mach 2, it will take 2X, no matter what you do. Actually, it will take a bit more than that, but you get the point. It's like, it will not change. So what people are saying is very efficient and all that is the number trigonometry. What does that mean? That simply means, if I say high voltage DC line is 50% more efficient than high voltage AC line, that is mathematically true, but there is a trigonometry happening. So that trigonometry is that if you have 1000 kilometers, basically A to B, and you are transferring energy over high voltage AC line, let's say 100 kV AC line, not 100 kV, 100 kV is too less, 500 kV, 500 kV AC line, you're gonna lose 6% of it. High voltage DC line is gonna lose only 3%. So that's what it means. That's what 50% means. But if you are just hearing that 50%, it may sound odd. It's like 50% means we are wasting 50%. No, we are not wasting 50%. It's just of that total 100% of lost energy, we are only losing 50% in comparison. So instead of 6% loss, you have 3% loss. Same applies here. So when they are saying it's more efficient, it's not more efficient compared to basically Jumbo Jet Airbus A380. It's more efficient compared to Concorde. Let that be very clear. And if sometimes they are like direct comparison, it's like, oh, Airbus A380 consumes this much and we are only going to consume this much, it's very little. It's like, yeah, but Airbus A380 could carry hundreds of people, hundreds, not one, two, hundreds. So yeah, you see, there is some manipulation with number that's giving efficiency. It's like law of physics is clear. You cannot breach it, you cannot bypass it. And military systems could do it. That's why almost all modern fighter jet can touch Mach 2 easy. But they have no budget limitation. We do not talk about budget. Like, there is a meme in USA where it's like, military budget is not a budget. It is like accounting how much we spent. It's not a budget. So same thing. Like, could US government build SR-72 that will have Mach 10 capacity? In principle, yes. In budget, maybe. But it's one of those things. Like, can you do that in commercial ecosystem? No. Another thing is how the missiles can sustain it. Like, India has BrahMos missile that is Mach 3.2, and it can do that. Like, there are other missiles also that are like Kinzhal, that is Mach 5. How? Well, it's the time. Time duration is very small, meaning even if it has a hot body, it gets hot, it only gets hot for a few minutes. Meaning, if you take a metal object, let's say titanium, and you heat that puppy to 500 degrees Celsius, okay, that's bad, but only heat it for 20 minutes. Not that much is going to happen. Heat it for 3 hours, it's gonna lose structural integrity. So same thing happens with missile. It takes time to reach to that hot point, and by the time it reaches that hot body temperature, whereas the structural integrity would be compromised, it's already at its target and it's about to go boom. So missiles do not have to worry about the temperature as much as you think. Because a jet that is for passenger, that has to be in that speed range, has to be in that hot body configuration for hours, that's a different thing. So fuel cost is an issue for economic system. Let that be very clear. SR-71, it was expensive for army because it required a different fuel compared to their all other jets. Imagine how expensive it would be for you and I if we have to buy a fuel that is of that grade. Yeah, no. It's just like fuel is not going to work. Let that be very clear. I'm not talking about in terms of engineering. It can't be done. I'm just talking in terms of economics. It can't be sustained. Same way SR-71 could not be sustained. So fuel cost is the issue. And there are not that many rich people. Let this be very clear. There are rich people that are getting richer and richer every day. That is absolutely true, mathematically true. You can calculate it based on tax returns, based on uber rich people. And there is directories for that. And it is true. However, the numbers of new rich people coming into the market, it's not growing. The amount, now, of course, the scammers have been growing exponentially, but that is a problem because that not only erodes trust from the market, but it also burns a lot of wealth. So number of new sustained rich people are not adding up. It's basically, we reached a quiet down period. After World Wars, we always have a boom period where things grow exponentially. World War II actually created a very exponential whoa. Now that whoa is over now. Like we went to the moon, man. Things are done, over. But now it's a cool down period. So in that cool down period, we're gonna build a faster jet. Yeah. Mm-mm. So there are not that many rich people that can afford free flying on passenger jets that are like Mark II. That's the whole point. And inflation has been too high for too long. Too long. That's the issue part. Inflation itself is not the issue. You track inflation of like last 200 years in America. It's always going dinka chika. But it's like for last 30 years, it's been like, yeah, it's going like bit much. The acceleration is getting accelerated now. So that's the issue. Like there are people who are buying yachts, but here's the, now more and more people are like, oh, I'm buying third yacht for me. It's no longer like, oh, I'm also in the yacht club. It's like, yeah, the same old people. So that's the issue. There are not that many rich people, and even government have limits in terms of army spending. So Maverick has to tame it down. So what can we expect in the future? Well, there is a lot of interest. Let's be very clear. Things are happening right now. Aviation industry is reaching a stagnation period where things have been ironed out. We figured out we cannot build ultra jumbo jets like Airbus A380 is too big, and regional jets are the king. I still have not seen a 4 engine jet. Like I really want to see a 4 engine jet, man. I've only seen dual engine one. I've ridden in planes also, but like only dual engine. Never seen 4-1. So people have realized like dual engine is the key. Things are stagnated. It's like sorted, cool, man. So there's a lot of interest for something new. This sounds new and interesting. The fact we had it, so there is a nostalgia there. It's like, oh, we want it. So a lot of startups have entered in the game. So we have Boom Supersonic, and they are doing few things clever. First thing, they know that if they change the aerodynamics signature to make it quieter, it will make it more difficult from economics point of view. So they are like, we are only gonna fly over the land. Like that's their business model. They are not even attempting to go across American sky, and they are not traveling at Mach 2. They are traveling at Mach 1.5. Why? I do not know. Most likely, of course, I know from an engineering point of view, it will reduce the headache, it will reduce the stress loading and all that, thermal hot body, all of that. That's cool. But it's like, it will sound ugly. It's like, yeah, we used to travel at Mach 2, we are still not traveling at Mach 2. So from a marketing point of view, it sounds odd. But okay, they are doing that. And then you have Hermes, that these puppy are trying to make Mach 5 jet engines. Can that be done? Yeah, we have technology. We have ramjet, and we have air breathing jet engines. Problem is getting them to work together. SR-71 was a pseudo ramjet. Now what you have to achieve in order for Mach 5, you want to achieve a clean, basically your airflow path has to be complete. It cannot be a pipe, it has to be a duct at that point. You can see that in Maverick, when he's such a switching to scramjet, the doors opens up and the new air path opens. You need that. Only then ramjets can start. So Hermes, they are trying to make that. So success as a passenger, let that be very clear. Can technology allow you to build this? Absolutely. Can you have the fuel that can give you that? Yes. Can you reduce sonic signature? Yes. But the only thing that is uncertain at this point in time is the success as a passenger. It's very questionable from economics point of view, because I have clarified. You have science, basically physics, engineering, economics. Economics is very clear. It does not work out. It did not work out for, basically Conquered era. And be mindful, nowadays we have direct telecommunication, 4K telecommunication. Is it really justifiable at this point in time to actually go somewhere? Like you will, oh, we always have that. It's like, no, more and more people are like, yeah, we can just, call it. Of course, sometimes you would want to travel. And for that, we still are traveling at 700 km/h in normal jets. It's good enough, man. So the questionability from an economics point of view is very difficult, because be mindful, while there's so many private jets, there are only 25,000 private jets. Only 25,000. That's not a large number. And like again, jumbo jet is like Trump owns a jumbo jet, so you get the point. And there's a contradiction here. The contradiction is you're paying for speed over comfort, meaning the amount of money this company like Hermes or Boom Supersonic will charge for a jumbo, basically a private jet, would be so much that it will be comparable to a larger jumbo jet. Basically, you're buying a smaller high-speed craft versus a larger low-speed craft. And low-speed craft would be easier to maintain, cheaper to do, and you can have a bed. Like Trump's plane also has bed. You can have bed, and you're like, what are you gonna do in a bed? Like there are people who do things on bed. Like there are people who do things. Heck, if you have money, you can go into Las Vegas, and for $900 per hour, you can join the Mile High Club. So there's the issue where it's like two things are contradictory. Yeah, speed is paramount for army. They are like short up, take money. But for uber rich people, we have reached a point where we have worked around it enough where it's like, is it really worth it? Because again, you also have to ask, hey, could I buy one super expensive supersonic jet, or I buy two private jets? That gives me redundancy, that gives me failover, that also allows me to have renting facilities, because you will not be stranded if you rent out, because hey, I have a backup on. And again, you can easily schedule it properly so it does not intersect. So for many economical reasons, it does not work. However, let that be very clear. Does that mean all these companies are in danger? Economically, yes and no. Why? Because they are building technology. And then we have an ecosystem which we call minds bigger than yours. So in this minds bigger than yours, all these companies like say Lockheed Martin, Boeing, and all that military contractor, they're like, dude, keep developing, man. But don't worry about my budget. It's like, oh, you went bankrupt. Here's money. Here's buyout. If they prove that they can build Mark 5 jet engines, which is of course a real jet engine, and then switch to Ram engines, and it works. It's like a thing that works. I cannot tell you how many military companies, especially cruise missile manufacturers, would be like, how much for that system? Like, we will not ask, like, here's a blank check, go YOLO on it, give me that technology right now. Like, I can guarantee you that there are companies that are like, wait, you have what? Mark 5 on a jet from standing still. Here's money. Give him the engine. There's a blank check. Sign whatever you need to. And you're like, oh, we have built a hot body structure that allows avionics to be like, low speed here going Mach 2. They're like, shut up, take money. We have like, a lot of cruise missiles are very long range, but they are slow. Imagine those slow cruise missile being, oh, it's only Mach 2 cruise missiles, and Hermes would be like, Mach 5 cruise missiles. Shut up, take money. Like, let this be very clear. While from a commercial point of view, I do not see that much hope there, but from a technology point of view, from like, I build this tech, can I sell this tech too? It's like, shut up, take money. Like, mine's bigger than yours. It has to be bigger. It has to be bigger. So this was my presentation on the new interest on supersonic ecosystem. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.